So what I want to do tonight is to do a review for test 2. So test 2 is going to open tomorrow, and it'll close on Sunday night at 11:59. Now, also, there is an extra credit quiz on my math lab, and it is just extra credit, but the thing is, it should help you prepare for the test. I did add the extra credit into the test grades for test 1, so I have to do that manually, but I already have added those in. And doing this extra credit quiz should help you. And even if you don't complete the whole thing, you'll get some points. So, like, say you get a 50% on the extra credit quiz, I'll take 50% of 5 points, which is 2.5 points, and I'll add that to your test grade. So, anyways, hopefully y'all are seeing that out there. Now, this is, I believe, section 1.5, transformations. So you need to know how these things affect the graph of a function. So we've got, this table here, and let me see. Okay. So vertical shifts, that's when you add or subtract a positive number on the outside. So you're not doing it inside the grouping symbol, you're just doing it on the outside. And if that number is positive, then, or actually, if you're adding the number, we're assuming these numbers are positive, then this is going to shift it up 4 units or k units, and this will shift it down k units. Then that's the vertical shift. A horizontal shift is when you're adding or subtracting a number inside the grouping symbols. So, like, by grouping symbols, some of the grouping symbols that we'll see, I'm not sure this is everything, absolute value bars, square roots, or cube roots, or squaring, or actually a fraction bar. Oops. Tell me if I go off and you can't see what I'm doing. See, these are all grouping symbols. So if you're adding or subtracting h inside grouping symbols, it does something different. It actually is going to shift it horizontally. So that means left to right. And it's a little confusing in a way, because if you add, like up here, if you add a positive number, it shifts the graph up. So it's increasing actually the y value. But if you add a positive number inside the grouping symbol, it shifts it to the left, so in the negative direction. And if you're subtracting, it shifts it to the right. And I went over an explanation of that in the lecture, I believe, looking at a table of values and everything. So you just need to remember this. Compressing or stretching, I don't think we did this one. But for this one, if you multiply on the outside of a function, so you're just multiplying whatever the function is by some number a, and a is positive, then what it's going to do, because this f of x is y, so it's going to multiply all the y coordinates by a. And if a is greater than 1, it's going to stretch it vertically. And if a is between 0 and 1, it's going to compress. So for instance, say we had some parabola like this, and then say we do some kind of compression, say this is f of x, and then say we do 2f of x, it's going to make it skinnier. And if we were to do 0.5 f of x, it's going to make it get fatter. And then this one's getting skinnier. Now, and that's when A is positive. If A happens to be negative, and we multiply on the outside of the function times a negative, or actually, they're actually breaking this up. So this is for the A, which will either stretch it or compress it vertically. This is doing the negative sign. If it's on the outside, it reflects the graph of f across the x-axis. So this is the x-axis right here. So if you've got a graph like that, it's going to reflect it across the x-axis. And if the minus sign is inside the grouping symbol, then it's going to reflect it across the y-axis. So if it looked like this, say it's a parabola, and then it's, or let's do one that's not right, symmetric with respect to the y-axis. Let's do, let's see, how about let's do a absolute value. And then if it's going to, and that's f of x, then if we're going to reflect across the y-axis, then it's going to look like this, something like that. And so that's going to be f of minus x. Okay, so those are the transformations that we have, and you have to understand them. And stop me if you have a question. So here's an example. And I believe I do this in my lecture video. I know when I teach it face-to-face, I do an example like this. But let's just do this one. So suppose that the x-intercepts of the graph of y equal f of x are -5 and 3. Then what are the x-intercepts of the graph of y equal f of x plus 2? So let me go down here. Move this up so we can see it. Okay, so we're talking about f of x plus 2. Well, this is going to shift horizontally left 2 units. So, and that's because we're adding inside the grouping symbol. So if the x-intercepts are -5 and 3, so the x-intercepts, and you can think of them as ordered pairs, they'll be -5, 0, and 3, 0. So if we're shifting to the left 2 units, then you're going to be subtracting 2 from the x values. Because this does a horizontal shift, it doesn't affect the y value. So if I subtract 2, so I'll have a -5 minus 2, that'd give me a -7. And if I subtracted 2 over here, that'll give me a 1. And so the new x-intercepts would be -7 and 0 and 1, 0. Okay. Let's look at B. So B says, what are the x-intercepts of the graph of y equal x minus 2? So if it's y equal x minus 2, which way is it going to shift it? Anybody? Can anybody tell me? It's still a horizontal shift because it's inside the grouping symbols. And we don't even know what this graph is, but we can still tell what it's going to do to these x-intercepts. So it's going to shift right 2 units. So we'll take the x values, which are -5 and 3, and we'll add 2. So that'll give me a -3. So now we'll have -3, 0 as one x-intercept. And then the other one, the value is 3. And so we're going to be adding 2 to it. That'll give me 5. And so the other x-intercept is 5, 0. And that was B. Okay, then C. What about if we multiply f of x by 4? And so when you multiply f of x by 4, you're really multiplying the y values by 4. So what's going to happen now, it's not going to affect the x values. So the x-intercepts, it was given that they were -5, 0, and 3, 0. And remember, I'm putting zeros here because x-intercept is when y is equal to 0. Now, I can multiply the y's by 4, but since I'm multiplying, and I multiply the y's by 4. But since it's 0, since the y values are 0, the new x-intercepts are just the same. So it doesn't change the x-intercepts. So I guess I shouldn't say new, they just stay the same. So there's no change in this particular example of the transformation. And then the D part says, what are the x-intercepts of the graph of y equal f of -x? And now the negative is inside the grouping symbol. So let's see. So remember, if it's inside the grouping symbol, it's going to reflect across the y-axis. Because your x values are getting multiplied times -1. So like if you think on a number line, or if you just think about the x-axis, 1, 2, 3, -1, -2, and a -3. If we're multiplying the x values by -1, then it's going to reflect, this is the y-axis, whatever the values were over here. Like say it's an absolute value function, it's gonna go over here. It's going to reflect that way. So now that would change the x-intercepts, and our x-intercepts were the -5, 0, and the 3, 0. So we're multiplying the x by -1. So that means that the x-intercepts are going to be 5, 0 and -3, 0. So, the graph had, and I don't really know what kind of graph this is, but it had x-intercepts here and here. And so now it's going to have x-intercepts here and here. So if it had gone like this, now it's going to go like this. Did I get that right? Let's see. This was -5, and then this is 5. Oops, I think I got it. Didn't draw it right. Let me draw it again. I don't want to get this wrong. I'm going to confuse you guys. So the old graph had intercepts -5, 0, and 3, 0. And then the new graph's going to have 5, 0, and -3, 0. So maybe I did have that right. I'm not sure. So it's going to look like that. So that flipped over, or this flipped over, will look like that. I don't draw real well, but anyways, that's kind of the way it would work. Now, so that's the type of question that I could ask you about transformations. I will also ask you to graph a transformation. So be sure that you're able to graph transformations.
I have a question.
Yes.
Will this recording be somewhere?
Yeah, I put them on our YouTube channel.
Oh, okay.
Yeah, it tells about that on iCollege and it gives the link. So all of our, our lecture videos and everything are on the YouTube channel.
Okay, thank you.
Have you not been watching them? I didn't
No,
know.
I've been watching them, but I didn't know that those were part of the lecture channels. I thought it was like those were just videos, like normal videos. I
Well,
didn't,
no, I put the Zoom sessions that we have every week. I put those out there too.
oh, okay,
And so
cool.
this one will be at the very top.
I've been looking from the bottom up. That probably explains it.
Well, yeah, that might be the problem because I put them at the top, hoping that you can find them there. Okay, so be able to graph transformations. I'm trying to think, is there anything else about a transformation? I don't know if there's a problem like this or not. I can't remember, but we did have some problems like this, or we talked about it anyways. Like if you had a graph that say went like that, no, I think that's when we're talking about inverses. I don't think that's here. So let's not worry about that right now. Then what we've got is I want to write the function of the graph of y equal f of x, but is shifted up 2 units. So I'm going to do these one at a time. So first I'll write what the graph would look, or what the equation would look like if it shifted up 2 units. So for the number 1, it would be y equals the absolute value of x plus 2. Because, adding on the outside of the grouping symbol shifts it up, and subtracting would shift it down. And reflect about the x-axis, and you just have to remember this. That means that the minus sign is outside the grouping symbol. Because if it's reflected about the x-axis, this is the x-axis. So if it looked like this, then it's going to reflect and look like this. So really what's happening, the y values are getting multiplied times -1. And then shift left 3 units, then you would have y equal absolute value of x plus 3. And then 4, all 3 of the above in the order stated. So the way it would go y equal minus x plus 3. And then it should be plus 2. Okay. This should be a -2. All right. Because if you think about it, if we're doing it in this order, then when we reflect about the x-axis, then this would get multiplied by -1 as well. So if this were and this is kind of what it would look like. This would make it shift over 3 units, so its vertex would be right there. And then if we were adding 2 to that, it would be like up like this. But then if we reflect everything across the x-axis, then it's going to be down like this. So you would be subtracting 2. Okay. Let's see. This is just a little word problem, and it's just a linear function. So we've got, we're getting towed. And I'm always worried about getting towed. The cost C in dollars for having a car towed is modeled by the function C of X equals 2.5X plus 85, where X is the number of miles driven. So then they ask these questions like, what is the cost if you are towed X equal 40 miles? So for A, you're just going to go C 40. And so you're going to put 40 everywhere that X is. So this is pretty straightforward. And then you just multiply it out and you get 185. So it'll be $185 for towing a car 40 miles. Now the B part says, if the cost is 245 miles, how many miles will you tow? So you see, we put the 40 here because it is going where X is. This is going to go where the cost is. So in B, you're going to put the 245 where the cost is, and then you're going to have to solve for X. So you can subtract the 85 from both sides. And I believe that gives you 150. No, it doesn't give you 150. What does it give you? I think it gives you 160. You can check me on that if you want to. So then I have 160 equals 2.5x. And then I'll divide both sides by 2.5. And then I get x equals 64. So it's 64 miles. So the car was towed 64 miles. Now, the C part says, suppose you only have $150. What is the maximum number of miles that you can be towed? So what I'm going to do, really it's setting up an inequality. So this is C. So I would say $150 would be greater than or equal to 2.5x plus 85. And then I'm going to solve this for x. So I'm going to subtract 85. And I believe this is where you get 150. You can, not 150. This is where you get, I think you get 65 here. Does that look right? 550, yeah. And then we divide both sides by 2.5. And then that's going to give us 26. Or I should say like this, really it's going to give me the 26 over here. So 26 is greater than or equal to x. So what that means is the most miles that the car can be towed is 26 miles. Okay. If you tow more than that, it's going to be more than $150. Okay, and then let's see. That was C. D, what is the implied domain of C? And here's C right here. C of X is 2.5X plus 85. So the implied domain in this word problem, you wouldn't be towing a negative number of miles. So the implied domain would be from 0 to infinity. That's the domain, or that's the implied domain. Because it just wouldn't make sense for the number of miles to be negative. And then interpret the slope. Well, the slope in C of X equals 2.5X plus 85. The slope is always the coefficient of the X. And so we're talking about a linear function when we're talking about slope. This is a linear function. So the slope, and we use M a lot of times for slope, is 2.5. And so what that means is the cost, and this is one way to say it, but the cost increases by 2.5 for each mile towed. And this is what we call the variable cost. Okay, it's the variable cost because depending on what X is, this part's going to change. And so that's the variable cost. And this part right here is the fixed cost. So no matter how many miles you are towed, you still pay this $85. So even if you were if you were towed, less than 1 mile, you still have to pay the 85 plus 2.5 of whatever percentage of the mile you were towed, assuming they would do that and not just charge you $85. And then the last question is interpret the y-intercept. So the y-intercept in this function, and it's always going to be out here, and you can think of this in the form y equal mx plus b, and that's the slope, and this is the y-intercept. Because if you let x be 0, which is what you do to get the y-intercept, you get b. So the y-intercept is just y equal b. And you could also say the cost of 0 miles would be, I'm sorry, that should be 85. Would be $85. And this is just the fixed cost. And a lot of linear functions have, a fixed cost and then a variable cost like this. So anyways, that's that little word problem. Questions, anybody? Okay. Then start talking about quadratic functions. That was a linear function. So with quadratic functions, there's a lot that we talk about with quadratic functions. We study them a lot. They occur a lot in the real world, because if something like, if you throw something up and then it's going to come down because of gravity, that's in the shape of a parabola. And a lot of other things are are going to turn out being in the shape of a parabola. Now, a quadratic function is going to be in the form f of x equals ax squared plus bx plus c. So that looks different than a linear function. It will have a square term. It might not have these two terms. B and C could be 0, but A can't be 0. So this is a quadratic function. And some of the things we do is find the x-intercepts, which are also called the zeros. And basically, when you go to find the zeros of a function, and we aren't really talking about the non-real zeros, but the real zeros are the x-intercepts on the graph. So we want to do this. I want you to know how to do it. I'm not going to have you solve an equation completing the square. You can if you want to, but what I specifically would like for you to do, and I might have you show your work so I actually see that you're doing what I ask you to do, is to find the zeros of the quadratic function. So basically, I'm setting this, I'm setting the function equal to 0, whatever the function is. Now, some quadratics can be factored. Some you can use the square root property, but some you can't. Some cannot be factored, and you really wouldn't use the square root property. So on those, you would use the quadratic formula. So you're going to have to memorize the quadratic formula. And guys, don't use a cheat sheet. If you do, you're really just cheating yourself, because you're going to need to know all this stuff when you go into the next class. And if you go into calculus, you're going to need to know this. And you also, our last test and the last quiz and the final are all going to be on iCollege, and I will be recording you. And the system that records you will flag any. I mean, it'll flag if you have a cheat sheet, or you get up, or you do anything suspicious. So please go ahead and learn this, and don't use a cheat sheet. And I mean, that's just a good thing to do. You're paying for an education, so get one. That's all I'll say about that. So I want you to be able to solve by factoring, because we need to know how to factor. We use that all over the place. The square root property, and the square root property says that if x equal b squared, if x squared equal b, then x equals plus or minus the square root of b. That's the square root property. Factoring, there's techniques and formulas for that, depending on what the quadratic looks like. So I've got these quadratics down here, these quadratic functions, and I want to solve one by factoring, one by using the square root property, and one by using the quadratic formula. Now, this one would be the one that you would want to use the square root property on. And you would do that when it doesn't have, it doesn't have the x term in, the formula for the quadratic function. I'll write it again. If it only has the square term and then the constant, you can use the square root property. So because I'm finding the zeros, I'm going to set it equal to 0. And you can call this the zeros or the x-intercepts. They're the same thing. So I'm going to set 0 equal to x squared minus 20. And then the first thing you've got to do is isolate this x squared. So I'll just add 20 to both sides. And then I'll use the square root property. So then what I will get is plus or minus the square root of 20 equals x. Now that's not in the most simplified form, and if it tells you to simplify, then you're going to need to simplify 20. So when you get to this point, you look at what's under the square root, and if it's divisible by any perfect squares other than 1, then you need to simplify it. And perfect squares, here's just some of the perfect squares. 4 is a perfect square, that's 2 squared. And then 9 is a perfect square, and then 16 is a perfect square, and 25 is a perfect square, and 36 is a perfect square, 49 is a perfect square, and on like that. And so when I look, and if it helps to write those numbers out, go ahead and write them out. When I look at this, 20 is divisible by 4. So I would go like this, plus or minus, and it's 4 times 5. So then you go ahead and you take the square root of 4, which is 2. And so here's my answers. So in this case, there would be a positive 2 times the square root of 5, and the y value is 0, and then there'd be a negative 2 times the square root of 5, 0. And those would be the x-intercepts for this function. And you could graph it and you could see that. Now, let's see if this one factors. If it factors, we'll use factoring. The way you can tell if it factors, go 6 times negative 2. So you're taking the leading coefficient times this number right here. Now, be sure you've got your quadratic in standard form. So it has to be in this order. So if it's not in that order, you need to get it in that order and set it equal to 0. So let me see if I can factor it, because when I do that, I get a negative 12. If I can find two numbers that add up to the coefficient right here, 1, so we need to find two numbers whose product is the negative 12, and the sum equals whatever the coefficient in the middle is. So are there two numbers that would multiply to give me a negative 12 and add to give me a 1? Yeah, a positive 4 and a negative 3. Wouldn't that work? Okay, so now the way you do this, and I'm going to go over here so I have plenty of room to do it. So let me go right up here. If I use, and now if you have another method for doing this, because there are some that are taught in high school where you use like a box method. I've seen students do it, but I don't actually know how it works. This is the way I do it. So you take these two numbers that I just came up with, the 4 and the negative 3, and I'm just going to go ahead and write the 0 here. And always, before you do this, check to see if there is a number that divides out of all the terms, because that'll make it simpler if there's a greatest common factor, divide it out. But there isn't, other than 1. So now what I'm going to do is I'm going to use the 4 and negative 3 over here. And the way I'm going to do it is I'm going to take this middle term and I'm going to write it as a plus 4x minus a 3x. And then I've got my minus 2. So I turned it, and that's these two together would give me a positive 1x. So I turned it into 4 terms, and now we're going to factor by grouping, because that's how you factor if you've got 4 terms. So I'm going to group the first 2 terms together. Now you have to be careful here because I've got a minus sign that's going to go in front of these parentheses. So I'm going to have to change this number in the parentheses so that if I were to distribute, it would come out to be what I started with. Then I look and I'm going to factor the greatest common factor out of these two terms. And the greatest common factor is a 2x. And then I'm going to factor the greatest common factor out of these two terms. They don't have anything in common except for 1. So I would write the 1 there because I think it'll help you do this correctly. Because and these should be the same. If they're not the same, you made some kind of mistake or it doesn't factor, something's wrong. But these should be identical. So they are. So now what I do is I factor out, this is a common factor to the two terms. I factor out that common factor. Be sure you use your parentheses everywhere. And then what's left is a 2x and a minus 1. And now I have it factored. And then I set each factor equal to 0. And this is called the zero product property. That basically, if you've got two numbers or 3 or 4, however many, and the product is 0, then one or both of them has to be 0. That's the only way you can get 0 when you multiply numbers together, is if one of them's 0. Now that's only true if this is 0. It's not true if it's 1 or 2 or 3, but it is true if it's 0. So then I'll have 3x equals -2, or x equals -2/3. And here I'll have 2x equal 1, or x equal 1/2. So these are the x-intercepts. And when a quadratic function factors, your x-intercepts are going to be they're going to be rational numbers. So what that means is it won't have square roots and stuff in here. Now, the last one, this one right here, notice if you try to factor this one, so you would go 2 times -1, and you try to find, and that gives me a -2, two numbers that give me a product of -2, but a sum of -3. And there aren't any. Because the only way you're going to get a -2 is a 2 times -1 or a -1 times 2. And neither of those add up. Neither of those pairs add up to be a -3. So this won't factor. And that's true. Some quadratics cannot be factored, but you can always use the quadratic formula. So that's what we're going to do down here. So I'm going to use the quadratic formula. And so you have to have that memorized. Okay, and then where the A and the B and the C come from, it's up here. If this is in the right order, then A is the first coefficient, B is the second coefficient, and C is the last term. So that's A, B, and C there. A, B, and C. Then I'm just going to go substitute these values in here. And be careful with your signs. That's where I see a lot of the mistakes. And then, make sure you have substituted in everything correctly. And so I got minus and -3. Yeah, that looks good. Now, what I would do, and over 2a. I almost forgot the 2a part. So this will be 2 times 2. And that fraction bar goes all the way across like that. So then x is going to be equal to a +3 plus or minus the square root of 9, and then go ahead and do the sign here. You've got a minus times a minus, so that's going to become a plus. And then 4 times 2 times 1 would just be 8. And then in the bottom, we've got 4. And then just, add that together. And see, notice that this is an irrational number. That's, because we couldn't factor it, then the answer is going to have to be something irrational. And so these are the two x-intercepts. One of them is 3, positive 3 plus the square root of 17 over 4, and then 0 for the y value. And the other one is 3 minus the square root of 17 over 4 and 0. And if we were to graph the quadratic, we could tell that these were the x-intercepts. What's the y-intercept going to be? Well, for the y-intercept, you just put in 0 for x. So g of 0 would just be equal to -1. It's easy to find the y-intercept, but it can be some work finding the x-intercept of a quadratic function. Questions, anybody? Okay. Oh, let's see. Sure. Okay, so here we want to find where these two functions intersect. So one of them's quadratic and one of them is linear. And what I'm talking about here, we're going to work it out algebraically. But, I think I'm supposed to show you how to do this with your calculator as well. So I'm going to go ahead and do that. So let's clear this out. And let's graph the two functions. So one is 3x squared minus 7. And that's the quadratic. Oh, and I want to reset my window. Or let me just go back to Zoom and set it just to standard. And so that's the quadratic. And then the linear, where am I? Okay, so it's 10x plus 1. Okay, so you see that they're intersecting here, and they are also going to intersect somewhere up here. Now, there is a way to do this with the calculator. You won't get the exact values, but why don't we do it algebraically first, and then I'll show you how to do it with the calculator. So what you want to do, so you're trying to find where these intersect. Then you set them equal to each other, and you're going to solve for x. So I just set the two functions equal to each other. Now, I want to get it in standard form. It's going to be a quadratic. So I want to get it set equal to 0. So I will subtract 10x from both sides. And so it'll go away over here. And then I've got the -7, and I'll subtract 1 from both sides. So then I have 3x squared minus 10x. And then I have -8 equals 0. So this is my quadratic. So I'm just got to solve this. And so, I can use quadratic formula. It's not set up to use the square root property very easily. I mean, you could complete the square, and that's what completing the square is, turning it into something that you could use the square root property with. Or you could see if it'll factor. So to tell if it'll factor, multiply 3 times a -8, and that gives me a -24. And so I want to see if there's two numbers that have a product of -24 and a sum of whatever this middle coefficient is with the sign there. Okay, so how about 12 and 2? Would that work? If I take a -12 and a +2. And I know I'm going to make the 12 negative because this middle term is negative. So I want the bigger number to be negative. And then that means I'll make the 2 positive. And that'll multiply to give me -24. And it'll add to give me -10. So then what I do, I'm going to do the factoring by grouping again. I take the 10x up a little bit. And I break it down using these two numbers. And you know, if you have one negative and one positive, if you write the negative first, you won't have to worry about changing the sign in the middle here. But of course, both numbers could be negative, so then you'd have to. Oh, and then I want to factor by grouping. Okay, so I've got it set up to factor by grouping. So I'm going to group these two terms together. And then I'm going to group these two terms together. And remember, there's a plus or minus or whatever in the middle. In this case, it's a plus, but that needs to be there. And then I factor out the greatest common factor here, and it happens to be 3x. And put that plus sign there, factor out the greatest common factor here, and it happens to be a 2. And then it's working because these are the same. So then I factor out that common factor. And then what's left is the 3x and then the +2. And then I use that 0 property and I get x = 4. And then over here, 3x + 2 = 0. 3x = -2. X equals -2/3. So now the points, those are 2x values. 2x values because there's 2 points. To get the y here, you have to go back into either function and not the one where we set them equal and got this new function, because we know that if we substitute a 4 into that, we're going to get a 0. But if you go back to either one of the functions and substitute in a 4, you'll get the y value, and it should be the same regardless of the function you use, because we're talking about a point of intersection. So that means a point that's on both graphs. So if I go to, say, find f of 4, so this is what I'm doing down here. So I get 3 × 16 - 7, and that's 48 - 7, and so that's 41. So one of the points of intersection is 441. Then I have to do the same kind of thing over here with the -2/3. I'll just use the other function. It doesn't matter. So I'm just going to go g of -2/3. And that's going to give me 10 times -2/3 plus 1. Here, I'll do it so you can see what I'm doing. So then that's going to give me a -20/3. And I'm adding 1, and 1 is 3/3. Getting the same denominator, and so that gives me a -17/3. So the other point is -2/3, -17/3. So you really answered the question. These are the 2 points. They're not, they're not x-intercepts or anything. They're where these two graphs intersect. Now, if I wanted to do it graphically, you can do it with your calculator. It's not going to give the answer. It may not give the exact answer, but it'll give an approximation. So we start, and I'm going to find this point. No, I think I'll find, well, okay, let's find this point first. So I'm going to go second function calc. And then I'm going to go down to where it says intersect, or you can just enter a 5 there. And where it says first curve, it wants you to be, see how we're down near here? We're going to get this point of intersection. So it wants to be on the first curve. So I can just hit enter here. And then you want it to be on the other curve. And let's see. Hold on just a minute. Let me start over again, because I'm not sure which curve I started with. Okay, so I want to do the intersection. And so the first curve is this one. So I could just hit enter. And then I want to be on the other curve. So, I think I could just hit enter right here. Let's see if that'll work. And then for the guess, hit enter. And so it gave me these values. Now, I don't know. What if I go math? I don't know if this will work or not. No, that won't work. So let's just go back to the graph. And let's go back and find the intersection again. Sorry, I just was trying something there. So I'm going to find the intersection. So I'm going to go, I'm already on the first curve, I'm on the second curve, and this then just a guess. So now notice I got this minus 0.66, and the sixes keep going. And then I got this -5, and the 6, and the 6, and the 6 keep going. Well, that's really this value right here. These values right here. This is -2/3. And if we go -17 divided by 3, oops. I think I know what I did wrong here. I did this. I did the minus sign instead of the subtraction sign. That was that other value that we had right there. So this is the same as this. Except, well, this is really giving an approximation. This is the exact values. Now, if we wanted to find that other point of intersection, then what we've got to do, so we go back, second calc, and we go to the intersection. You have to go way over towards this other point. It's somewhere, I think it should be hitting the trace key. Where am I? Oh, okay. And I can't really see it. I think what I'm going to do is I'm going to change my window setting so that I can see that. And so I'm going to let my Y min be 0 and my Y max, and I know it's 41. So I'm going to make my Y max be 50. And I'm going to scroll by 10, say. And I'm going to see if this will work. So then I'm going to go graph. And you see right here, that's that other point of intersection. So let's go second function calc, pick option 5. And now we want to be over, near this point. So, okay, so I want to hit enter. Oh, hold on just a minute. I don't think I'm doing the intersection. Just a second. Oh, well, look at that. I did do it. It gave me 4 point, it's not exact. And then it gave me 42. It might not be exact because, let's try it again, because I didn't start out very close to that point. Let me go second function quit. Okay, and then go second function calc, go 5. And then I'm already over there. So, well, yeah, so I should just hit enter. and hit enter again. Oh, okay, look, this time it gave me the exact value, the 4 and the 41. So I guess when I was sitting right there, it's going to give me the right value. And you notice it can give you something different depending on what you're giving for the starting value on the on one graph and the starting value on the other graph. And if you're like positioned over here, it's going to give you that other point of intersection. So that's how you do it. Any questions about that, guys? Am I going too slow?
No.
Okay. I know I can get kind of carried away and go into too much detail, I think. And so I don't want to bore you completely. Properties of quadratic functions. So, and this is 2.4. We're going to be talking about the vertex. And I don't really remember it this way. So for the vertex, let me make sure this is the next thing I was doing here. Yeah, I think so. All right. The vertex is like if you've got a quadratic, it's either going to be shaped like that or like that. Basically, it's going to either be going up or going down. So the vertex is where it changes from either decreasing to increasing or increasing to decreasing. So this is the vertex. And this is the vertex of this one. And this is going to be if A is negative, and this is if A is positive. Because remember, the function looks like this. Okay, so now what we're saying here is that the vertex is going to be the point HK. And the way you get H, well, there's two ways to do it. And I'm going to ask you to do it really both ways. One way is to put it into what we call vertex form. This right here, or here it is right here. This is called vertex form. And if you've got it in this form, then whatever's behind the minus sign is the H, and whatever's out here is the K. But you have to put it into this form by completing the square, and I'll show you how to do that. And I do want you to know how to do that. But if you don't have to get it into this form, especially like in a word problem, and you just need the vertex, H is always going to be minus B over 2A. You have to remember that. And the K is going to be, just put the minus B over 2A back into whatever the function is. And that'll give you the Y value. They do it this way. And I just never remember that. You can do it that way if you want to, but I just always think, well, I get the X and then I just put it back in the function and I get the Y. So anyways, you need to know this. Know how to get the H and the K, and that's the vertex. Sometimes they call this the vertex formula, but they call this vertex form. So when it's in this form, it's the parabola of y equal a times x squared shifted horizontally, h units. And then so it depends on whether that's a minus or a plus, whether you're going to shift to the right or the left. And then shift vertically k units. As a result, the vertex is at HK and the graph opens up if A, this value, also this value, if it's not in vertex form, is positive. So that's opening up. And then down if the A is negative. And so that would be A negative here. The axis of symmetry, and so I'm going to ask you all these things. I'm going to ask you if it opens up, down, what the axis of symmetry. The axis of symmetry is always the line x equal h. Because if I could draw well, the graph would be symmetric about this line, which is x equal h. Or over here, it'd be symmetric about that line and that line, because it goes through that point, which is HK. So it's a vertical line, and so it's X equal H. That's the axis of symmetry. And sometimes we can use that to help us graph the function. Okay, so let's look at this example. First, put the function in vertex form by completing the square, and then determine the following. So here's the function. So to put it in vertex form, you group these two numbers together, and you leave this out by itself. And then what you're going to do, and I'm going to go ahead and leave a space here, because I'm going to end up adding a number right here to complete the square. And whatever I add, I'm going to have to subtract over here. So the way, because this is actually whatever we add in here will complete the square and make this into a perfect square trinomial. So the way you figure out what to add in there, you take this coefficient and you divide it by 2 and you square it. You just take the coefficient of X, divide it by 2 and square it. So that's going to give me 1 squared, which is 1. So I'm going to add a 1 right here. So then I'm going to subtract a 1 over here. Why am I doing the opposite? Well, we're on the same side of the equal sign. And sometimes they put this stuff over here on this side of the equal sign. But I was taught this way, but you can do it the other way. But it's amazing. I remember how it was taught. But if you add 1 and then you subtract 1, you really haven't changed the equation. So it's not, we can't go and actually change this equation. We can just put it into another form. So if you add, you got to subtract the same number. If you subtracted a number in here, you would add a number over here. And then the next thing we do is to factor. So we have f of x equals, and then this is going to be a perfect square. I know that. So I know that it's going to be a perfect square because I figured out what numbers should go there to make it into a perfect square. And it's going to be x plus a 1 squared. It's always going to be the number. It's always going to be this number, not this number, but it's always going to be the 2 over 2 if that's what it is that goes right here. And then over here, I've got the minus 9. And that's a square. Now, this is in vertex form. Okay. So, vertex form says f of x equals a times x minus h squared plus k. That's vertex, the vertex form. Now, the vertex here of this function, because you see, this is the way the formula goes. So if there's a plus sign right there, you can think of it this way. The plus would be like a minus 1. So the h really is a minus 1. So if there's a plus there, then the h is the opposite of whatever's added. So that's the x value. And the k is just whatever's out, the number out here. And that's the vertex. Now, is this graph going to open up or down? Well, the a, just remember, this is in the form f of x equals ax squared plus bx plus c. And the a here is just a 1. And 1's greater than 0, so it's going to open up. So that means it's going to look kind of like this. Okay, so let's go up here and answer some questions. The vertex we just got was -1, -9. It's going to open up because the a was greater than 1. Oh, and let me just write the vertex form up here too. It's x plus 1 squared minus 9. Whether the graph will have a maximum or minimum, Well, if it's going to open up, it's going to have a minimum. Because see, the vertex is right here. It's always either going to be the bottom of the graph or the top of the graph, depending on which way it opens. So then it's going to have a minimum. And that minimum will occur at H, and the minimum will actually be K. And we'll talk about that in the word problem. The axis of symmetry is always going to be X equal whatever H is. So it's X equal -1. And then the domain of this, the domain of any quadratic, unless somebody's restricted it, it's just going to be all real numbers. So in interval notation, the domain is just from -infinity to infinity. But the range for a quadratic, it's not going to go all the way up and all the way down. Like in this one, it keeps going up, but it only goes down to this vertex. And that vertex, see, this point here is actually -1, -9. The y value, and so when you're talking about range, that's what's the y value. What is the y value doing? When you're talking about domain, that's what the x value is doing. X's are going to keep going this. But the y, it's only going to go down to right here. So the way you say the range is that it's going to go from -9 to infinity. I included -9 because it does actually have a point where the y value is -9. The intercepts, well, we'll have to go find the intercepts. Let's see. And, since I've already got it in vertex form, it's fairly easy to find the intercepts, a little bit easier, I think. So let me see if I can move this down a little bit. So here is the function. Okay, so to find the x-intercept, remember we set y equal to 0. So we have 0 equals x plus 1 squared minus 9. And if it's set up like this, it's easy to use the square root property. You could use any method that would work to solve this quadratic. But all I have to do is add 9 to both sides. And then using the square root property, it says that if x squared equal b, x equals plus or minus the square root of b. So then plus or minus the square root of 9 is going to be equal to x plus 1. Now, we know what the square root of 9 is. It's 3. And then if I just subtract 1 from both sides, I get my x-intercepts. So the two x-intercepts, we have x equal -1 minus 4. And so that's going to be a -5, 0. And then we have x equal -1. I'm sorry, that wasn't just, that was supposed to be a +3 here. I don't know why I put a 4 there. -1 minus 3 is going to be a -4. And then the other one will be -1 plus 3. So that'll be x equal 2. So the other one is 2, 0. I believe that's right. So those are the x-intercepts. The y-intercept's easy to find. The y-intercept, here's the function. Just set x equal to 0. So it'll be 0 plus 1 squared minus 9. So it'll be 1 minus 9, which is a -8. Oops, sorry. See that? So the y-intercept is 0 minus 8. And then they want us to graph the function. So I'm going to just try to graph this by hand. And then I thought I had a piece of graph paper here. I'm not. Where did the graph paper go? You know what? I'll just show you where I've already graphed it on this page over here. You know, the way I did it, I plotted the vertex, which was the -1, -9. I know it's opening up, so it's going like this. This is the y-intercept right here was 0, -8. And then the two x-intercepts, this was 2, 0. And the other one was -4, 0. And then this is the axis of symmetry going right down the middle. And it's just the vertical line, x equal whatever the x value is at the vertex. And then you could check it with your calculator or graph it with your calculator. But that's how it works. Okay, let's see. What else have we got here? The rest of it maybe isn't too bad. Okay. Well, this is just talking about the discriminant and the x-intercepts, which are the zeros of the quadratic function. Remember, x-intercept just means the zeros. It's really the real zeros, but we don't really talk about non-real in this course anymore. I don't know why. But anyways, if the discriminant, and let's just call that D, is b squared minus 4ac. That's the discriminant. Now, you know, in the quadratic formula, it's the discriminant is just the part under the square root. And so if it's negative, then that's not going to be a real number. And so if it's negative, there's not going to be an x-intercept. So that means that the graph does not cross or touch the x-axis. Now, if it's positive, then there's going to be two x-intercepts, because if this is positive, you'll do one where you add this, and you'll do one where you subtract this, like we just did. And if this actually equals 0 right here, square root of 0 would be 0, then you're only going to have one x-intercept, and it's just going to be minus b over 2a. This is an a right here, because this part would be 0. And so that means there would be one x-intercept. So I may ask you to find a vertex, find the discriminant and describe the x-intercepts. I'll just make something up right here. Like say it's f of x equals 2x squared plus x plus 7. Okay, the discriminant is going to be the b squared minus 4ac. So it's going to be b here is 1 minus 4 times a is the 2, and c is the 7. So I'm going to have 1 minus 4 times 2 is 8 times 7 is 56. So that's going to give me a negative 55. Okay, so D is negative. So that means there's going to be no x-intercept. Now, what does it look like if there isn't an x-intercept? Well, it's either going to be all above the x-axis or it's going to be all below the x-axis. And since this opens up, it's going to be all up here. So it doesn't necessarily look like that. We can go and graph this in particular. And so I've got 2x squared plus x plus 7. And see, there it is, and it's not going to touch this x-axis. Okay? So, you can graph it and tell how many x-intercepts it's going to have. You know, it might have 2, like we looked at a minute ago. It might have 0, And if it only had one, it would just be touching the, oh, I'm drawing on my, I'm writing on my calculator. But it would, actually, that's not so bad. It erased. It would be either looking like this, you know, or it would be looking like this. And it would just be touching right there. Okay. So I could ask you a question about that. And then maximum and minimum values of a quadratic function. We talked about that a little bit. Whether it has a maximum or minimum is determined by this value of a, which tells us whether it's going to open up or open down. And we know that the vertex follows this formula. So if it opens down, and that's when a is negative, there's going to be a maximum at the vertex. And if the a is positive, it's going to open up, and there's going to be a minimum. And that's just what this is saying here. And then the maximum value is actually the y value at the vertex. Now, where it occurs, what is it, the x value? That does make a difference, you know, which is the x and which is the y, because, you know, you think about if you've got a word problem and your boss wants to know, okay, how many chairs do we need to make to maximize profit? And say it turns out that the numbers are, you know, 25 and $5,000. I don't know. If you say we need to make 5,000 chairs and the profit would be $25, that is totally wrong. So you need to say that you need to make 25 chairs and the maximum profit would be $5,000. So, you know, that's one thing that we use quadratics for. Quadratics model a lot of functions that have to do with business. And the vertex is important because it's where the either the maximum or the minimum occur if it's a quadratic. Okay, so like in this problem right here, you want to determine whether it opens up or down, find the vertex, the axis of symmetry, the y-intercepts and the x-intercepts. I don't know if I'm going to do all of this. So I've already done all of it. Where did I do it? I've already done all of it before. Because I've been talking so long and I don't want y'all to just die or anything, I'm going to go ahead and show you the answers to this, where I worked it out. I think I've got it anyways. I did it. Let's see. Here it is. This is where I worked the problem out. So I didn't put it in vertex form because it didn't say I had to. So the quicker thing is just to use the formula. And so I got this for the h, and then I went back and I put the 1/2 into this function, and I get a -5/2 for the k. So that's the vertex. It's going to open down because that's a is -2, and a equals -2, that's negative, so it's going to open down. So it's going to open down like that. It's going to have a maximum. So then I just plotted the vertex here, and I found the x-intercepts. It didn't factor, so I used the quadratic formula, but then it turned out that you get a negative for the discriminant. You could have done that in the beginning to see that the discriminant is negative. So it's not going to have any x-intercepts. It's not going to touch the x-axis. And then I just went and found the y-intercept. It's going to be -3. And so 0 over -3 down. And so then you can plot that point. That's 0, -3. You can plot the vertex, which is 1/2, -5/2. And then because this is the axis of symmetry right here, x equal 1/2. And so if this is at the x values at 0, so you actually added 1/2, then you're going to add another 1/2 right here. And so there's going to be a point right here that's going to be, you added, subtract a half, add a half, 1/2, and the y value's going to be -3 because of the symmetry. And then where is it increasing and decreasing? Well, you see it's going to have a maximum, and it's increasing. So let me write this out. Oh, I did it over here. Okay, so I graphed it a little bit better over here. And the domain is -infinity to infinity. The range is, it only goes up to -5/2, and then it keeps going down. And it's increasing from -infinity up to 1/2, the x value of the vertex. And it's decreasing then from 1/2 on. And remember, with increasing and decreasing, in interval notation, these are the x values where it's increasing from x equal -infinity, which means just keep going this way, up to x equal 1/2. Then it's decreasing from x equal to 1/2 to infinity. Let's see, what else? What else? Just have a little word problem right here that's a quadratic, and then we'll almost be finished. What I have here? Yeah, then we'll have this quadratic inequalities. So this is a word problem. It's a little bit, got a lot of words to it, but it's not really that hard. It's a business application. The monthly revenue R achieved by selling X wristwatches is figured to be R of X equals 75X minus 0.2X squared. So revenue means the money that you're bringing in by selling these watches. So of course it depends on how many watches you sell. And it's a quadratic. The monthly cost of selling X wristwatches is 32X plus 1750. So here, this is a variable cost depending on how many wristwatches you make, and this is the fixed cost. Now, how many wristwatches must the firm sell to maximize the revenue? So we're talking about finding the maximum of this function. And if you write this function in, like down here, I wrote it in standard form, which is really what you need to do, because you know standard form goes so it looks like this. It doesn't have a constant term, but you can tell whether it's going to open up or open down because the leading coefficient here is negative, so it's going to open down, so the vertex will have a maximum. So we need to find the x value, and so that's the the h, which is the x value, equals minus b over 2a. So I go minus b over 2 times a, and I went ahead and I rounded up because you're not going to make half of a wristwatch. So I just went ahead and rounded up. Then to find the k, you just go, in this case, the function's r. So r of whatever you get for the x. So I did that. I just put the 188 back into the function, and I got $7,031.20, I believe is what I got. Now, the next part says that the profit function is given by revenue minus cost. So, you're bringing in so much money, but you're having to spend so much money. So if you take the money you're bringing in and subtract the cost and hope that it's positive, That's the profit. And a lot of times we want to maximize profit and revenue and minimize costs, basically. So I have to figure out what this profit function is. So I take the R of X, which is this, and I subtract the cost function, which is, where's the cost function? Right here. And so I do that here, and then I get this profit function called P of X, and that's supposed to be an equal sign right there. That's an equal. And when I combine like terms, I get this, and it's in standard form. And then I find the H again for this function. And then I put that number, and it's about 108, I round up, put that number back into the P function, and I get the Y value here, which is $561.20. So the maximum profit's going to occur when you make 108 wristwatches, and what the maximum profit is going to be is $561.20. Okay, that number is so much bigger. I wonder if that's, seems like those numbers would be closer. Let me check this. I'm just wondering. I just want to make sure I've got that right. So I want to check this number, which is minus 0.2. Oh, you know what? I'm not going to check it, because if I made an arithmetic mistake, y'all can catch it. I just am surprised that these numbers are that far apart. So I would question that when I'm looking at that. I think I may have made a mistake. Now, it says that provide a reasonable explanation as to why the answers in part A and C differ. Well, I mean, A is going to be higher because you're just talking about the money that you bring in from selling the watches, and you're not talking about subtracting the cost, whereas in C, you have to subtract the cost. So maybe these numbers are right. No. But anyways, that's that question. Now, the last thing that we had were quadratic inequalities. So, this is a quadratic inequality. It's a quadratic, and it's got an inequality sign. Now, there's two techniques for doing this. The easiest one is just to find the boundary numbers, graph it, and answer the question. The other method, and I believe I do both methods in my lectures, is to actually, you find the boundary numbers, which are the x-intercepts, and you make a little chart and you figure out what the answer to the question is. But either way, you want to get 0 on one side, and you can just set it equal to 0. So subtract the 5x and subtract the 3, and then we're going to solve this. So I figured out how to factor it, using that grouping method. This is what it factored into: x equal 3 and x equal -1/2. Now, if you're just using the graph, you go and you graph y equal 2x squared minus 5x minus 3. So we graph that on our calculator. Now, it asks, what it's asking is, when is 0 less than, or no, let's do it the other way. When is this function 2x squared minus 5x minus 3, when is it less than 0? Okay, if I move everything to this side, and then it'll be less than 0. Less than 0. And so you're talking about, this is f of x, this is the y. When is the y less than 0? Well, it is when the function's below the x-axis. And so if you look at the graph and you know that these are the intercepts, so one of them is x equal negative 1/2, and the other one is the other intercept was 3, x equal 3. It's below here between negative 1/2 and 3. So the answer then is it's when negative 1/2 is less than x, but x is less than 3. And you can write it like that, or if you write it in interval notation, it would look like this, x 1/2 to 3. That's when it's less than 0. Now, if you wanted to know when it was greater than 0, it would be from negative infinity up to negative 1/2, union with from 3 to infinity. So if you were talking about that, it would be two different intervals, and you'd have to use the union symbol. But if you're talking about less than 0 in this example, it's only one interval. Now, the other method, if you can go read the lecture and look at the other method is to draw a number line and put the negative 1/2 and the 3 here. And then you test in the inequality. So like over here, you could say test -1, because that's over here on this side. So you go back to the inequality. You can go to this form or where it's set equal to 0. It doesn't matter. And so you test again this 2x squared minus 5x minus 3 less than 0. And so what's going to happen here, I know by looking at this, is it's going to be false here. And it's going to be, so that's false. It's going to be true in the middle. And it's going to be false here. But I already know that. But if you didn't know it, like in here, you could test x equals 0. Some number that's in here between negative 1/2 and 3. And over here, you could test, say, x equal 4. So it's just more work to go and test all those numbers in there. Then if you can just understand that when you look at the graph, if it's the inequality is less than 0, that means below. And also you're not going to use square brackets because it's only less. It's only less than. If it had an equal sign there, you would put square brackets here. Then I forgot what I was saying. If you understand, this means below the x-axis, and if it was greater than 0, it would be above. Okay, I think, let me see. I'm going to show you one more word problem because I might ask one like this, and I just want to mention one thing about this. This is a quadratic word problem where you're throwing a ball up with an initial velocity of 80 feet per second. The distance s in feet of the ball from the ground after t seconds is s of t equals 80t minus 16t squared. And the way this comes from, this minus 16t squared, and if you write it in standard form, that would be written first. And then this 80t would be here. The minus 16 here comes from gravity. It's the gravity that's pushing down. And this 80 comes from the initial velocity. So that's how they get this formula. And this is called the position function. So you can determine where the ball is depending on how many seconds have gone by from the time you threw it. Now, if you want to know when it's going to strike the ground, the thing that you've got to remember, when will it strike the ground? It's always going to be when s of t equals 0, because the position is going to be 0 when it hits the ground. So basically, it may start at the ground or it may start somewhere else, but it's going to end up at the ground. And so I just did that. I took it and set it equal to 0, and I factored it, and I got t equals 0. So it starts at the ground, and then it's going to hit the ground again after 5 seconds. And then for what time t is the ball more than 96 feet above the ground? Well, then I want this, the position, to be greater than 96. So this position function is greater than 96. And then I just subtracted the 96. I could factor out a negative 16, and then I was able to factor this, and I get t equal 3 and t equal 2. So the ball is above 96 feet between 2 seconds and 3 seconds. Oh, and you would need to graph to see this. So you would have to go and graph y equals negative 16t squared plus 80t minus 96. And it's going to be opening down. I know that because this is negative. And so when is it above, somewhere in here, there's going to be the 96 feet. And so it's going to be above 96 feet between here and here. For the t values where it's here and where it's here. I guess it's going like from here to it. Well, let's think of it going from here to here. And so that's for t equal 2 seconds and t equal 3 seconds. Okay. Question. That's it, folks. Don't forget about the extra credit quiz. I think I already told you about that. Any questions, anybody?
I don't have anything right now.
You don't have anything right now? Well, just ask me if you do. And Parker, do you have anything?
No.
Okay, well, thank you guys for coming and being patient. It did take quite a while. I hope it helped. And that's kind of the review for the test. So the test is going to open tomorrow, and it'll close on Sunday night at 11:59. Okay. Well, then I'm going to stop the recording, and